All right, we're going to start the second lesson in Unit 3 today. So if you want to turn to page 8, that's where we'll be starting. Okay, so here on page 8, we're still talking about decimals and operations with decimals in this one. So we'll be looking at some multiplying and some adding and subtracting and those kind of things. So here we have the important stuff. Again, we are on page 8, starting at the top. And you can look through these 6 problems here, and you notice that we're either going to multiply or divide by 10. Now, because we use a base 10 system, and a base 10 means that there are only 10 different digits, multiplying by 10 is very easy. In fact, and dividing by 10 is very easy. When you multiply or divide by 10, all you have to do is move the decimal point. And that's what we're kind of discover here going through these first 6 problems. Okay, so number 1 here, they give us 0.6, and then you multiply by 10, you get 6. 6 times, so the decimal is here. Okay, it went from here to the right one. When you go from 6 times 10 is 60, so we move the decimal to the right again. And then 60 times 10 is 600. You moved the decimal to the right place again. When you divide, though, you are moving the decimal to the left. So 0.6 divided by 10 is 0.06 or 0.06. Number 2, we have 70. 70 divided by 10 is 7. And you could put 0.0 if you wanted. 7 divided by 10 is 0.7 or 0.7. And 0.7 divided by 10, again, you're just moving that decimal to the left, is 0.007. Sorry. Too many zeros. 0.07. Okay, here we're multiplying by 10, so you're moving the decimal to the right. So 0.002 times 10 is 0.02. Okay, got rid of one of those zeros. And then 0.02 times 10 is 0.2. Okay, you just move that to the right one spot. So multiplying, so we can write up here, multiply, move decimal to the right, and divide, move decimal to the left. Okay. So 0.34 divided by 10, so you're going to move that to the left one. You get 0.034. Divide by 10 again, you move that to the left again, you get 0.0034. And again, the zeros are just placeholders here. 0.81 divided by 10, you move that to the left, so 0.081. Times 10, you move it to the right one, so 8.1. And 8.1 times 10 is 81. Okay, we got 905 times 10. The decimal's right here, so move that to the right one. You get 9050. Dividing by 10, we're going to move it to the left one, 90.5. Divide by 10 again, you move it to the left again, 9.05. And divide one more time, you move it to the left, you get 0.905. Now, the patterns that we discovered in the last unit with the number line still apply here. So number 7 says fill in the space so the sums are equal. So you have 2 plus 8 equaled 10. And 2.1 plus what equals 10? Well, you moved it this way, 0.1. So then this one also has to go this way, 0.1. So this number gets bigger while this number is going to get smaller. And 8 minus 0.1 is 7.9. So 7.9 and 2.1 added together make 10. And we can tell that because they are surrounded. They are the midpoint, or the number in the middle of them would be 5. Okay, so on 8, circle the sums that equal 10. It says relax, don't do anything more than you need to. Okay, so basically you could add, okay, you could go through and add all those numbers, but you know, a couple things add up to 10. You should know that 5 and 5 add up to 10. You should know that 6 and 4 add to 10. We could go 7 and 3, 8 and 2, 1, 9 and 1. So you should know that those add up to 10. So if I take this 8 and 2 and I go the same distance away from each number, kind of like I did over here, I know 8 and 2 equal 10, but if I go 0.1 less than 8 and 0.1 more than 2, that also equals 10. So we're looking at patterns here. So we know 6 and 4, okay, are there any, all the rest are decimals. Well, 7 and 3, no, or 7 and 2 is a no, because it should be 7 and 3. Okay, so let's look at 2.2 and 7.8. We know that 7 and 3 add up to 8. So if I go 0.8 more than 7, okay, and 0.8 less than 3, I'm going outwards, okay, on the number line over here. If I, let me draw a number line right here. Well, let's just use this scrap paper right here. Kind of visualize this. I know that 3 and 7 add up to 10. Well, if I go to 7.8, that's over here. So that's a 0.8 difference going that way. And I go 0.8 difference this way, 2.2, that's 0.8, that's 0.8. They will still add up to 10. Okay, this was 10, and then this will be 10. As long as the distance here is the same, and we either go out or we go in, it doesn't matter. Okay, so this is 10. Okay, so you can look at the number line. You can also look and see if you add the decimal, you should get 10, and then you should get one of these. So 8, 9, 10. So 0.8 and 0.2 is 10. So then you would have 5 and 5 here, which is good. Okay, this is also 0.2 above 5 and 0.2 below 5. So that equals. Okay, so you have 5 plus 5 is 10, but then you would have 6 and 5. Well, 6 and 5 or 4 and 7 doesn't cut it. Here you got 2.4 and 7.6. 6 and 4 make 10, and then you would have 7 and 3. So that would work, or you would have 8 and 2. Okay, here we've got 6.1, so that's 0.1 above 6. So this would need to be 0.1 below 4, which it is. So that works. This is 0.9, or let's say 0.9 below, sorry, this is 0.1 below 9. So this needs to be 0.1 above 1, or yeah, above 1, which doesn't work. Okay, plus 9 and 3 doesn't make 10. Okay, this is 0.7 above 6. and this is 0.7 below 4, so that works. Okay, or you can say this is 0.3 above 3, and this is 0.3 below 7. Okay, so you got that pattern there. 8, 9, and 10, you can determine whether these mobiles are balanced without having to add up either side. If they are balanced, write equal in the blank below. If they are not balanced, circle the heavier side and write less than or greater than. Okay, so we did these before with kind of when we started with the inequalities and finding the missing values here. So let's just see here. So I've got 0.5 and 0.5. We're going to go this direction. So 0.5 or 5.2 and 5.2, those are equal. So we're going to write plus 0. Okay, that doesn't matter. Those will always be the same. And then we have 0.9 and 4. So this is plus 0.1. Okay, these sides are we'll call them zeros. Plus 0, plus 0. Those are zeros. And this side would be my 0 and 0.1. So this side would be heavier, so that side is greater than, and I haven't really added anything up. Okay, again, we're going to say that this side is our zeros. All right, and going from 5.2 to 5, that is a minus 0.2. Okay, and going from 3.9 to 4, that is a plus 0.1. Now, since these sides are 0, you have negative 0.2 and plus 0.1. Okay, so one of those cancels out, and you end up getting an overall score of negative 0.1. Okay, it's a negative 0.1. So this side is less than this side because it was negative. So that side is more. Okay. You could look at it a different way. We started with both of these as zeros. You could look at which side is heavier. Okay, out of these two numbers, 5.21 and 5.23, this side is heavier by 0.02. Okay, now looking at this, these two, 4 and 3.98, this side is heavier by 0.02. Now both sides have a 0.02 on them, so they are equal to each other. They balance the same. Okay, so you could do it by just making this first column zeros and seeing out which one's heavier, which one's smaller, or you can just look at the positives on both sides. Okay, number 12 on page 9. Fix these answers by placing a decimal point where it needs to be. Okay, so you have 12.5 plus 24. Well, this would be 24.0, so there's 0.5 plus 0.0 is still 0.5. So your decimal would go there. Okay, here if we add the decimals, they're both negative. So a negative plus a negative is still a negative. So you have 0.5 plus 0.4, which would be a 0.9. Okay, so you need that 0.9. And then negative 12 plus negative 2 is negative 14. Here we have 0.50 and 0.24. Well, 24 plus 50 is 74, so your decimal is right there at the 74. Okay, and those it didn't move. Sometimes when you need to carry the 1, like if it adds up to 10 or 20 or something like that, you have a number to carry. Circle the best estimate. Okay, this symbol right here means is approximately, so it has been rounded or the number's been cut off or something like that. So you have 0.52 and 0.40. That way they have the same. So 52 plus 40 is actually 92. So that'd be 0.92. So it's actually 0.9 would be the closest. Okay, so they rounded those off. All right, on this one you have 0.50 522 and 21.41 something. Okay, so if we look here, we have 0 and 21. That makes 21. Okay, so which one's close to 21? This one is. And then you have 0.5 and 0.4. That's pretty close to, that's 0.9. So this number would be really, really close. Okay, and that's what we're looking for. You have 0.05, 0.04, both negatives, and you're adding. So 0.05 and 0.04 is 0.09. So that one would be, this one's got an extra 0 in there, which I wouldn't want. 2.45 and plus 0.045. Okay, so you've got a 2, 4 and 0, that's a 4. So something around that would be close. This looks the closest, so we'll go with that one. This green, on number 19, this green line connects two numbers whose difference is 0.2. Draw 5 more lines that connect numbers that differ by 0.2. They differ by 0.2 because your scale here is 0.1 going all the way across. So you could say these two, okay, you just got 2 gaps there. These two, so that's 1, 2, 3. These 2 and these 2. It doesn't matter as long as there's 2 gaps in between them. And we could, mathematically, we would say 7.7 minus 7.5 equals 0.2. That's what you're looking at right there. Okay, and we could write that problem for each one of those. Where am I? Show all possible solutions. Okay, so we did these with numbers, positive and negative. So now we're just going to do them with the decimals as well. So I am 0.04 units away from negative 0.02. Where am I? Okay, so you have 0.02, and you're going to go minus 0.04. And then you got negative 0.02 plus 0.04. Okay. Well, from here to here is 0.02. And then from here to here, you have another 0.02. So this one is 0.02 for a total of 0.04. Okay. If you cross a 0, mark a 0. Okay. Because we want to look at those distances separately. Okay, I am 0.5 units away from negative 0.6. So negative 0.6 minus 0.5, okay, is negative 1.1. Okay, because 5 and 6 make 11. Okay, so you got your 11 there. And then negative 0.6 plus 0.5 is negative 0.1, because 6 minus 5 is 1. Okay, so you're really close to 0 there. 22, I am 0.12 units away from 0.04. Where am I? Okay, so you're going to go this way, and you're going to go this way. Now we're at 0.04, so zeros maybe right in there. Okay, so 0.12 plus 0.04, let's say, is right here. That would be 0.16. Okay, 12 plus 4 is 16. And we don't, it's not a 1.6 because it's 0.4 and it's 0.12. So you add your 4 and your 2 and your 0 and your 1. Okay, now between here and here is 0.04. Okay, so between this number and this number needs to be 0.08 to make your 0.12. So 0.08 negative. Okay, so 0.08 plus 0.04 makes your 0.12. Okay, it's the same kind of concept. We're just putting in a decimal point here. I am 0.2 units away from 0.3. Okay, so here's 0.3. If I go 0.2 units this way, that would be 0.5. And if I go 0.2 units this way, 3 minus 2 is 1. That is 0.1. Okay, 0 would be right there. We didn't cross it. I am 0.01 units away from 3. So here's 3. If I go this way, 0.01, that's 3.01. And if I go this way, 0.01, that's 2.99. Okay, because this is pretty much 300, and 300 minus 1 is 2.99. I am 0.02 units away from negative 3.8. Negative 3.8. If I go this way, remember we get smaller. Okay, so this is 3.80. Okay, so it would be negative 3.7. 80 minus 2 is 8, 78. And if I go this way, we're going to add it. So 380 plus 2 is negative 3.82. That was a 7 right there. Okay, so be careful. If you need to think about it as like whole numbers, 380, 378, 382, you can do that. Just remember where your decimal point goes. Okay, some more of these of who am I? I'm even, so that means this is a 0, 2, 4, 6, 8. The sum of my digits is 11. My tens digit is a perfect square. So that's a 1, 4, or 9. So the sum of my digits is 11. So if this is 0, this has to be 11, which it can't be. If this is a 1, this would have to be a 10, which it can't be. Okay. 9 plus 2. 9 plus 2 is 11. And 4 plus 7 is 11. I don't have a 7 over here, so we get a 92. Okay, I am a perfect square. So perfect squares again are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Well, it can't be that one, and it can't be these because we're at a 2-digit number. I am greater than 20, so that marks out 16. My units digit is 5 more than my tens digit. So this number is 5 more than this number. So 2 plus 5 is not 5. 3 plus 5 is not 6. 4 plus 5 is 9. And let's just check these others. 6 plus 5 is not 4. 8 plus 5 is not 1. So your answer is 49. Okay, you can, if you want, get started on the additional problems. It looks like those are on page 11 and 12, possibly. So you can get started on those, and then we will look at the second part of this lesson the next day. Thanks for watching, and we'll see you in the next one.